Thank you. Thank you for the introduction. It's a pleasure to be back on stage at Scala Days. We got a little bit of stage presence with Scala I/O, but this is we're finally back with the full Scala Days event, which is nice. And to compound with that, I'm here to talk to you a little bit about 10 years of Scala.js. Because yes, it's been 10 years. Before we started, there were actually a number of previous attempts. I counted 4 significant attempts at having some sort of JavaScript out of Scala. 2 were done at EPFL, 2 were done in the community, 2 were based on the compiler-based approach, and 2 were more DSL approached. You will find that the author of JScala is somewhere at the conference, maybe in the audience here. So clearly there was desire for it, right? We wanted to have Scala on the front end in the JavaScript ecosystem. Unfortunately, for a number of reasons, none of those 4 attempts really grew into something with a community, an ecosystem. So, well, who was I to make a 5th attempt and think it would work? Well, you'll see later that the story is not so much about me as about other people. So today, having Scala on the JavaScript platform is really the boring reality. Right? We have a rock-solid core with 0 known bugs at every release. A significant amount of the Scala ecosystem works both on the JVM and on JavaScript, and some of it also on native. So according to Scala.js, 36% of all Scala 3 libraries cross-compiled for Scala.js, right? Most importantly, we have a vibrant ecosystem of dedicated Scala.js libraries, and notably, of course, UI libraries, right? I will talk about that more a bit later, but without libraries for front-end development, there's only so much you can do, really, right? And besides libraries, you also want to have some tooling, and we'll see later that that's an area where we still have progress to make, but we now start to have some amount of integration with front-end tooling so that you can effectively develop front-end applications using Scala.js. And finally, as in this list of where we are, we have an enthusiastic community of users and contributors. Right? If you pass by the Scala.js channel on Discord, you'll see a number of very helpful people over there, and a number of people who also contribute libraries, tooling, books, etc., etc. So let me go back to the very beginning of Scala.js. The first commit was on February the 5th, 2013. So we officially celebrated 10 years in February of 2023. And to remind you a little bit of the context back then, right? Scala 10.0 has just been released. The latest SVT version was 0.12.2. And some of you may remember the fishy operators back then. And it was basically one developer in a lab at EPFL doing this. My brother would say it was one person in their garage. So it was really, really small and a long time ago. But right from the get-go, I found back a commit on March 14. So that was a little bit, 5 weeks into the development. There was a commit that said, added statically typed JavaScript classes a la TypeScript. That was the commit message. And it remains the foundation of interoperability in Scala.js throughout its history. What we had back then on March 14 of 2013 is essentially what we still have today as a foundation for interoperability with JavaScript. This is the code from back then, and people who use Scala.js on a daily basis today will find that maybe a bit off, but mostly it looks like typical Scala.js facades, right? You define trace that extends JS object, nowadays JS.object. You define apply methods, overloads, and you manipulate JavaScript objects this way, right? You define statically typed facades, and then you can interoperate with JavaScript directly. And so you can take the window object in the dynamic scope, select the jQuery object, say, trust me, this is an instance of this jQuery static, and then you can start calling methods and stuff like that. So nothing has changed, right? We had it all 10 years ago. A little bit later, I presented Scala.js for the first time at Scala Days New York in June 2013. So this is also an anniversary in terms of number of Scala Days events since the beginning of Scala.js. It was met with a lot of enthusiasm. It was the very last talk of the conference. In a small room, everyone was tired, but it was packed, and people were standing at the edge of the room. Got lots of questions. All of that despite the fact that if you asked for the size of the hello world, it was 16 megabytes. And so that we have changed. Going a bit forward in the story of in the early story, so the road to getting to a v01 on the technical side, well, we integrated with what we call GCC, nothing to do with the C compiler. It's a Google Closure compiler. It's a JavaScript to JavaScript compiler that performs a number of optimizations in terms of code size, mostly. That already brought down the hello world quite a bit down. We fixed a series of obvious code generation bugs. We made a usable SBT plugin instead of having to manually call the compiler and stuff. We switched to an architecture based on the compiler plugin instead of a fork of the compiler, which made it better integrated into IDEs and stuff like that. And we got a test suite. And back then, I was not known for writing good tests. In fact, the initial test suite was not even written by me. It was contributed by an external contributor, which is kind of very shameful at this point, but you live, you learn. Another aspect of the road to V01 was the social aspect, right? The community of enthusiasts. At that point, I'm not sure we could call it a community yet. It was a very small group of maybe 2-3 people. I was mostly used to develop tiny games and proof of concepts of, yes, yeah, it can work, maybe. I mean, I have a demo here, but we started to have some non-trivial contributions already, and that made the difference. When you start seeing outside people interested in your work and contributing to it and showing what they can do with it, it really has an effect, right? You start to have users. And when you have users, all sorts of weird things happen. In particular, you don't want to break them too often. Fortunately, we made the decision to break significantly in the first few months, not be slowed down by that, but eventually we changed that. So at the point we released V01, we had some, basically the fundamental design goals, the overarching design decisions about what Scala.js should even be were pretty well set. The first thing I really wanted to get right was I wanted interoperability with JavaScript. And I showed you we had that already 5 weeks in. We needed quite a number of refinements in the details to get to something really good, but that was clearly our defining number one feature, right? We want to be interoperable with JavaScript. We also want to be portable with respect to Scala JVM. So we want that if you write the same code and you compile it with Scala JVM or with Scala.js, it does the same thing. That's not necessarily a given, right? There are a number of programming languages out there that compile to several platforms, but they don't really behave the same on all of the platforms. And that has the unfortunate consequence that libraries written for one ecosystem may not necessarily work for the other ecosystem. So portability was quite important already for the project at that time. And then we wanted it to be usable with existing IDEs, build tools, and other tooling in the Scala ecosystem. Because, well, again, it was one person in the lab, and there was no way I was going to write an IDE plus a build tool in addition to a compiler, right? So we really wanted to work by default in IDEs and other tooling, and that puts some constraints, technical constraints, on the project. A bit later around in 2014 came the other two design goals of Scala.js as a whole. One is runtime performance, right? We want to emit JavaScript code that is as efficient as possible. And to some extent, to the extent possible, let's say, we want to reduce the emitted code size because no one likes to ship a JavaScript library that weighs 300 megabytes. So we have to pay attention to reduce the code size as much as possible. But that concern yields to the other ones, right? So if we need more code to be more portable, we will choose portability. So that is a trade-off that other languages choose to do differently. Other languages that compile to JavaScript want to reduce code size as much as possible at the expense of other concerns. Then the road continues, and from V01 to V05, it was a lot of stabilization, right? So all the fundamental design goals were set. We had the essentials, and now we wanted to make something pretty stable. Tobias Schlatter joined the project at EPFL, and we made he made a huge effort into making sure that the whole Scala test suite would also pass with Scala.js. Right? That was a huge undertaking, but we made it with some exceptions. And then we added our own dead code elimination to reduce code size further than what GCC could do. And then we also ran our own optimizer to make code efficiency better than what we had before. And finally came in 2015 at the 2-year mark. Precisely, I like anniversary dates. We released V060, and it was supposed to be an RC for V1. It was supposed to last for 6 months or so. If there are people in the audience who've been writing Scala.js for 5 or 6 years, you will remember that actually the 06X series survived for 5 years. Without breaking backward compatibility during all that time. And we added a lot of additional features and improvements, stabilizations, APIs over these 5 years without breaking anything. And Nicolas Stupri also joined the project during that time and was responsible for some of also that stabilization, notably with porting JUnits, so that we could write JUnit test suites instead of Jasmine, which is a JavaScript framework. So that improved our ability to write tests in an effective way. But that's all technical, right? It's one, now 2 people working on something. But really what made a difference in Scala.js 06 was the growing support of the Scala ecosystem. Until then, I think there were 3, 4 libraries that supported Scala.js to some extent. None of them were the widely used Scala libraries, right? But in 0.6, we brought cross-project, and that made a technical difference. It made it much easier, if some was still a bit awkward, to cross-compile libraries. But what we got was a lot of dedication from community members to actually make sure that the ecosystem would cross-compile to Scala.js. And so we had enthusiastic community members sending PRs to the maintainers of existing Scala libraries to cross-compile. In a lot of cases, it was only a matter of changing the build scripts and perhaps the CI scripts to match, but not a lot of code changes, right? And that, of course, is thanks to our portability commitments, right? We want the same code to compile and execute the same on both platforms. And then we also got some new libraries that were specifically designed to be cross-compiling. In that space, there was, of course, a number of Lihai's libraries, but on the topic side, it's a question of serialization without reflection, right? From that era, we got, based on earlier research on how to do that, we got really concrete ways of doing that because, well, there's simply no runtime reflection in the Scala.js world, right? So we need libraries that work without runtime reflection. In the Scala.js specific ecosystem, it's at the time that we got the beginnings of Scala.js React, which became quite popular among Scala.js developers, and it still exists today. We also got some other UI-related libraries, Scala tags, Scala.js Angular, and Angulate. Angular support has kind of fallen out of favor in the Scala.js community. It doesn't fit the Scala way of thinking so much. And we got, like I said, automatic serialization libraries. And we opened a Gitter room. If you remember that thing, it's from before Discord. So that also made a difference from a community point of view, right? Now you get to chat with other enthusiasts in real time and not just over a mailing list. I remember being quite reluctant to open the Gitter room at the time. I said, wait, but yeah, well, you want me to open the Gitter room, but think about all the time I'll have to spend in there and answer your questions. And they said, no, don't worry, we'll answer questions ourselves. And they did. I only answered the most tiny little gritty details of language-related questions, but mostly the community, grows itself, actually. All right, so that's for the early history. Now I will brag a little bit and say how much we have a very rock-solid core. And that I take credit for, along with Tobias and Nicolas and some of the others who helped really closely. So we have really high quality standards, strong code quality standards. We don't use Scala FMT because it's not good enough for me. My coding style is more stringent than what Scala FMT wants. We have the full Scala test suite, which is Partes for Scala 2, Vulpix for Scala 3. It amounts to about 2,000 tests who are cross-compiling, who are not about specific JVM features like threads or runtime reflection. Then we have the Scala.js specific test suites, which has about 9,000 tests in it. You might wonder, that doesn't seem right? There should be more cross-compiling tests than Scala.js tests. But in the Scala.js specific test suite, we have a lot of tests for the JDK implementation, of course, which is all clean-roomed, implemented, both the tests and the library itself. So that's the big amount of tests there. So you find a lot of tests for the Scala.js specific language features, for the JDK implementation, and then lots and lots of error cases. And if you've ever contributed to Scala.js core, you may have noticed that we are very stringent on pull request reviews. Sometimes it scares people away, but yeah, we still commit to have something where we don't we don't compromise basically on code quality. We also have very strong compatibility guarantees, right? We've had so strong compatibility guarantees in 0.6 that it's lasted for 5 years instead of 6 months. And especially on backwards binary compatibility. In fact, Scala.js was one of the first trio of projects that really committed to long-term backwards binary compatibility. And that was together with SVT and with Akka at the time. And when I say long-term, I mean we outlive the underlying Scala version lines, right? Our compatibility story spans for longer than the evolution, the life of development of the underlying Scala versions. In fact, last year, in December 22, we finally removed support for Scala 2.11, 5 years after 2.11 itself had been declared EL and hadn't received any more commits. Right? And then we fixed all the bugs. And when I mean all the bugs, I mean all the bugs. Bug reports have the highest priority, right? If there is a bug report in the queue, it's open, it's verified, we don't work on something else. We fix the bug. And since the release of Scala.js 1.7.0 in August 21, we have 0 known bugs every release, right? Every time we ship a release, in the issue tracker, you will find 0 open bug. And ironically, the 3 hardest bugs, the 3 last ones we fought to fix were library related, and they were about innocuous things, formatting floats and doubles, parsing floats. Doubles are easy, but floats, they're hard. And regexes to make them compatible with Java regexes. A corollary to this policy on fixing all the bugs with the highest priority is that you will find no good first issue in the Scala.js issue tracker, because if there was a good first issue, we would have fixed it already. Okay, that's the end of me taking credit for things. Because what really matters in the end is that you have a community of people who make your language thrive and not just be a compiler with a good test suite. Right? And the role of the community really cannot be overstated in this. I did not write, the initial talks I gave were not good. You can go back to my initial talks. I was doing a poor job at it. Now I like to think that they're decent. But they're talks that really engaged the community and provoked enthusiasm for Scala.js on a larger scale were given by other people, enthusiasts from the existing community. Tutorials were written, even books had first one chapter dedicated to it, and a bit more, etc., to books that do full stack applications and stuff like that. And I mentioned it before, but I will reiterate the effort to cross-compile the existing Scala ecosystem of libraries. And that is not only the Scala.js users sending PRs, but perhaps even more, it's the Scala library maintainers who did not really care about Scala.js at all. They were working on the JVM for their company, and that was it. But they accepted those pull requests, and they accepted the burden of maintaining that. And that I'm very grateful for, because if that did not happen, none of what we have today would be true, right? The only thing we could do to help them was make that cross-piling as effortless as possible, but it's still some burden, right? It does not disappear. And then all the UI libraries that are developed for Scala.js, they're all coming from the community. We did not do any of that. Speaking of UI libraries for Scala.js, this is the top 5, let's say, of what you will find today. We first have the square of regular UI libraries, and they're combined into two times two categories again. On the left, you will find the libraries that are Scala.js only. So they're entirely written in Scala.js, have no dependency on any JavaScript library, and that's Laminar and Tyrion. And on the right, you have facades or constructs around React. And then you also have the decomposition between the pure functional programming libraries, Tyrion and Scala.js React, versus the more FRP/object-oriented, which are Laminar and Slinky. So depending on your tastes for pure functional programming or not, and depending on whether you want to leverage a pre-existing React knowledge or whether you prefer to have an independent solution, there is something there for everyone. And then the fifth library in the big UI libraries is kind of an outsider. It's Indigo. That's a library for game development in Scala.js. So that lives in a bit in a separate world. But it's a very good one. I used it. I recommend. My personal favorite for UIs is Laminar, because I happen not to be a pure FP guy, and I like the Scala.js only ecosystem. So if I follow the grid, I have to use Laminar, right? I'll give you a taste of it, and well, I have code on the slides, but I might as well, if I use the right keys, show you a little bit of it. Just a couple things to give you a taste of what it looks like. So first, let me show you what this is doing. So we have on the right here, this is way too small for you, right? Can I make this bigger? No, because it's anyway. So on the right, you have this table of properties, and depending on which row is selected, instead of just having the value of the property, you get a text edit that will edit the property value, or you get a combo box if it's an enum, and then you can select something else. And all of that is pretty daunting to write for me, as I'm not at all a front-end developer, right? I take text as input and I output binaries or other texts. UIs are not my forte. I had a previous version of this application written in Scala FX, and this piece of UI was really complicated to write. Now this is all Laminar working in Electron, and I'll show you basically the entirety of the feature of the implementation of this feature. So we have a function that returns what should be the row of a table. You'll see I use the UI5 web components underlying, so there is a very nice library on top of Laminar that gives you static types for UI5 web components. So I use that. I return a table row. And then I have two children that are dynamic depending on things that come from above. First, I have the name in the first cell, the name of the property, and it comes from the signal here I have this inspected property thing. And then the second cell, it depends. It depends what I should put in the second cell depending on whether the row is selected or not. So what I do is I take the signal that tells me, is this row selected? And I map it. I test, is it selected? Then I return a property editor cell. And if it's not selected, I return a property display cell. And that's about it, right? I'm writing things in a very functional way. It's actually functional reactive programming, right? So there's one flow. I don't explicitly say, oh, that's changed, so now I need to modify something. I'm just declaring relationships between the data model and my UI, and then Laminar does the rest, right? The property display cell is a one-liner. I take the string representation of my inspected property data model, and I put it in a span. That's it. The property editor is a bit more complicated. I'm going to, again, look at the editor in the editor property of my inspected property, which is the part of my data model that says what kind of UI component I should use, right? So if it's a choice between a number of strings, so that's what we would get for an enum value, Then you're going to create me a string choices property editor. And then for a string choices property editor, what I do is I return a UI5 combo box. Its initial value, its value always reflects the string representation of my data model in the inspected property. And then every time it changes from as a user interaction thing, I take the new value, I put that together with my current value for the signal of inspected property, and then I send that to my function in the data model that updates the property. And changing the property in the data model will then feed back into getting back here and hence in the value. So it all fits together. And finally, I have, for each choice, I map this list of string to one combo box item for every choice, right? And that's it. That's it. You have here the full implementation of this feature, which was really complicated in Scala.fx or any other system where you have to imperatively change things and keep track of a number of things. Here, Laminar will follow the flow. So if you want more Laminar, come to our booth tomorrow afternoon. I will be live coding that very application, going a bit further, and we'll do some Laminar there. So now on the question of front-end tooling, we got scalably typed. The author of scalably typed is also somewhere in the conference. And that gives you access automatically to TypeScript type definitions. So since basically all the JavaScript libraries now have TypeScript type definitions, you can get them in Scala.js through scalably typed. And we recently developed a plugin for Vite, which is a live reloading tooling for JavaScript so that it integrates better with Scala.js. And again, really, there are friendly helping users hanging on in the Discord servers and in Stack Overflow. So you should come by. It's great. You will get all the help you might want. So where we are, well, we have a mature language and a mature ecosystem. According to surveys, it's actually used by 12 to 17% of Scala developers, which is significant. If you are 8 people in a group sitting somewhere, one of you is using Scala.js. The tooling is getting better, but we can do still better. And really using Scala.js has become the boring reality, right? And we have a great, vibrant community. So where are we going? Well, getting started with Scala.js needs improvement. Usually people say, yeah, it's going to take you a little bit of effort to get into it, but once you're there, it's great. But we should really make the getting started experience also great. So we started by publishing a series of tutorial series, both in written form and video with SVT, Vite, Laminar, scalably typed. But there's still work to do, so integrate client-server interaction, and also write the same tutorials, but with the alternative UI frameworks and or build tools. Also tooling, I mentioned it a couple times. This remains not our strong suit. We made recently huge improvements to the speed of the linker, so the feedback loop became much faster. The worst thing I saw as a reaction to when we published that was something who said, "That is great, our code base used to take 30 seconds to link, and now it's only 4. And I'm like, I was not even aware that there were code bases big enough that it could take 30 seconds to link, but apparently that exists, which must be in the hundreds of thousands or even millions of lines of code at that point, all Scala.js code, right? So imagine the scale of applications you can build with this. And we definitely need better integration with front-end tooling, and perhaps you have ideas about what front-end tooling we need to integrate better with, and if you well, come to me afterwards. We always want to be faster and smaller. In particular, a pain point now is GCC is holding us back because it doesn't really work with ECMAScript modules, and we really want to emit ECMAScript modules at this point. So we've reached a point where we need to implement our own global minifier, and then for all the local optimizers, minimization still offloads to an existing JavaScript minifier. But for all the global minification, we need our own at this point, which we haven't implemented yet. And well, there's always more optimizations to do on the generated code, of course. So with that, they always tell you at the school of how to give a good talk, do not end with a slide that says thank you. You have to end with a slide that is your takeaway message. Well, here's my takeaway message. I would really like to thank all of you, to thank the community, to thank the early enthusiasts, to thank the library maintainers who took over responsibility for cross-compiling and maintaining it. It's almost overwhelming to see the success that it has had, and I'm really looking forward to everything else we're going to build going forward. Thank you.